Good morning, everyone, and today is the fourth lecture for our course Introduction to Computing in Python, and we will be discussing today functions, how to define function in Python, how to pass parameters, and how to retrieve the expressions or retrieve the values from the functions that we have defined. Okay, so here is what a function in Python looks like. So the keyword to define a function is def, which is the keyword. Then you have a function name, and in parentheses you have the parameters that are to be passed inside the function. Now, just like we have for loops and if else conditions, here also the body of the statement is defined by specific indentations, and it goes like this. So first you write define, then function name, then parameters, then you put a colon, and anything inside after this colon with like two space indentation would be considered as the body of the function. So here then we write the body of the function, and whatever is returned is followed by return expression. So return is the keyword to return values from the function, which is same as we did in C, and the expression that you want to return. So let us have a look at an example. So here is a simple function that takes two numbers as input and returns its sum, right? So let me execute it. So, and let's say you want to get the sum of 5 comma 10, and we just execute it. So this just returns 5 plus 10, which is 15. So we use the keyword define. The name of the function is add. Parameters are two numbers, a and b, and inside the body we just take the sum a plus b and return that sum as we did here, right? Now you can, if you just want to print the sum, you can directly just get the return value and execute it. Or if you want to store it in a variable, you can store it like s equals to add a comma b, and you can also check the type of s, which will be in this case, since the uh, parameters that we have passed are integers. Now, one interesting thing is that we when we have defined these functions, we have not put a constraint on the data type, right? So what you can do is also add two strings in this. So you can just pass add like a comma b, and if you just print s, if you just print s, it will be ab, because since we know in Python there is no such hard data types, and what we have a variable is just a container, and whatever you pass, whatever you store in that container, the variable takes that data type. So using this function you can add strings and you can also add numbers. So this is kind of a this is the main difference between C and Python. Like in C you have to define the type of the data that you will be passing inside the function, but in Python you have no such constraint. It's rather relaxed. You can or you cannot, uh, depending on your action that you want to perform. Now, bringing things more formal, let's say if you just want to add numbers, right? What you can do is you can define functions with the data type of the parameters that you would be expecting. So the way to do that is same as before. So you just use define as the keyword to define. Then you have the function name, and then you pass the parameter list of parameters along with the data type that they should be, and you also give what should be the return type of the function. So here the return type of the function will be what will be defined by whatever you give input to the function. So in this cell, this sum will take the data type of a and b, right? But here the return value will be whatever you have set as the return type, right? And this is how you can define the function. So I have here written a code to compute powers, in which the first parameter is the base, which I have kept as int, and the second parameter is exponent, which of which you will be raising the power to. So base to the power exponent is essentially what will be computed here. Base raised to the power exponent is what will be computed here, and we will get the return type as int, right? So It is just a simple code which initializes just p with 1 and repetitively multiplies p with base till we have uh, as many times as exponent is passed, right? So let me just execute this block and see what happens. So if I write power of 5 comma 10, then we get 5 raised to the power 10. Okay, let me write a smaller value so that we know whether it is correct or not. Okay, it's working. Now you can also think what will happen if I pass 5.0, let's say, which is a float, right? So what happens is it will just override in that sense. Or you can see for what happens if I just pass 5.1, like let's say 5.3 to the power 3. What happens? So as you can see, this is just a way to say, but it is not hard and fast that it will be taken like this. It is expected to be integers, but it not necessarily be an integer. You can also pass floats. But what happens if we pass like a, for example, a to the power 3? Then what happens, right? Then it will say, then we can't multiply sequence by non-int type because it is of type str, right? Because the now we have passed the string and it is not a non-int type, so obviously it will throw an error. Now let me rewrite this add function with this parameter definition and let's see what happens, right? So we have a as int and we have b as int, right? And we return an int. Okay. Now let's see what will happen when I do sum of a comma b. So here it will throw an error, right? Because it is expecting an int and it cannot typecast an a to it cannot typecast a to integer, so it throws an error, right? Some can't. Oh, sorry, not some. It should be add. My bad. Sorry. So, yeah, this happened. Okay. So in this way, you can see that if it is just addition, whereas here it was multiplication, since the data type does not allow, string data type does not allow such kind of manipulations. So string does not allow multiplication, so obviously it throw an error. Whereas here, you can still add two strings irrespective of the data type. So it just worked fine. So one thing that we learned here is pass the even if you pass the arguments, it need not necessarily be considered strictly. For example, in case of C, if this was an int and if you tried passing a string or a character, it would have thrown an error. But in Python, it is much more flexible. Even if it is int, you can pass a string and still it will work, right? As we can see here. Let me try and change the name of this function. Let's see what happens. What if I do add one? Still it does. And what if I do mult on this thing? Then you will see that since string does not allow multiplications, it will throw an error. So if I do mult a comma b, oh, sorry. If I do mult a comma b, it will not do because it can't multiply sequence by non-int type of str. Okay, but if I do integers or floats like 2.6 times 2.6 times 8.6, in that case it multiplies. Even if it is not integer, it multiplies and it returns a value. Okay, so this is just a way to do it, but it need not necessarily be considered like this. So yeah, this is a main difference between Python and C, that in C, if you define a parameter, if you define a data type and attach it with a parameter, you can only pass that particular argument to the function. Otherwise you cannot. Otherwise you will run into a segmentation fault, or basically the function will not behave in the right way as it should. But in Python, you have that flexibility that even though it is an int, you can still pass floats, or you can still pass double or these kind of data types. And if the logic inside the function supports operations that are valid to the other data types that you are passing, it will still work, which we saw in case when we tried doing concatenation, even with the data types of the arguments defined as integers, it still accepted strings as a valid parameters. Okay, so in this way you can define a function along with specifying its parameter types and also specifying a return type. Okay, now if you want to specify what a function is supposed to do, what you can do is just below the defined statement of a function in triple quotes, inside triple quotes you can write whatever logic the function is doing. So for example, here I have power function which is supposed to return base to the power exponent. So I just write returns base to the power exponent. And if someone wants to see what this function does, it can just call this doc thing. So each function has an attribute underscore underscore doc underscore underscore, which essentially gives us the doc string of that function. That is what this function is supposed to do. So if I execute this, it will print returns base to the power exponent. So this is good for documentations. For example, if you're writing your own code and someone wants to understand what a particular function inside a file is doing, then you can just provide these kind of doc strings to make sure that user understands what this function is doing without actually going inside the logic of the function and trying to decode the actions of the function by giving different parameters. So this is also something that you can try out. Now here is another example of checking whether a function is whether a number is prime or not. So what we simply do is that if a number is 2 or 3, then we simply return true because it is these are known primes. But if number is 1 or if number divides 2, then we simply return false. And after that we keep on checking whether this number is basically what we do is we check till square root of n. If till that square root of n, if any number divides the particular number that is given as input, then we return false, otherwise we return true. So this is more like an optimized way of checking. So this is more like an optimized way of checking whether number is prime or not. So what you can also do is here you can just check while r is less than n, which we did previously, but this is more optimized way of taking while r is less than the square root of n. So if that happens, then basically basically the space in which in which you want to check becomes becomes logarithmically small. So it will just be log of whatever the space you are checking here. So if here you are checking for n objectives, you will be checking here for basically square root of n objectives. And if in this space any of the number divides r, then basically you have found a number that divides this number that you have passed as input, and it is not a prime. So you just return false. Else, if none of these things happens, then for sure the number is prime. So let me just execute this. So each prime for 78 return false, and each prime for 79 return true. As we know, 79 is a prime number. So these are just some examples of simple functions that you can that to give you an idea of how to define functions in Python. So you have to just remember the structure that first you have to give define keyword, then the name of the function, followed by the arguments, then a colon, and everything within 3 or 4 tab spaces will be considered as the body of the function, and anything outside it will not be considered as the body of the function. So just to give you an example, so here I will print inside body of function, and then we print outside body of the function. And if I just execute it, so yeah, this statement, since it was outside the body of the function, it executed, and is prime was called twice. So both of the time this line print inside the body of the function was printed. Right? So this is just a way to define a function in Python. and whatever you want to return, you can just return using the return statements. Okay. Now coming to the types of Python function arguments. So essentially Python supports four types of arguments, four types of ways in which you can pass the argument. So first, these are the exhaustive list. So there is default arguments, then there are keyword based arguments which are named arguments. Then you can also pass arguments by just giving the position, and you have an arbitrary arguments like variable length arguments args and star kw args. In this lecture we will only be going over the first three, because the last one will come into picture more when you have studied about various abstract data types, and then we can write functions which actually use those abstract data types, and we will see how they are used then. Okay. So the first type of argument that a function can take is default arguments, right? So by default argument, what we mean is that the parameter that you are passing in the function, you can essentially give the default value of them. So a default argument is a parameter that assumes a default value if a value is not provided in the function call for that argument. So here is an example. Now remember the power example that we were doing. So we just give the default values, like I want to just compute the exponent. If I don't provide any base, then the base is considered as 10, and if I don't provide any exponent, then the exponent is default value 1. And the logic is same, that we initialize a variable p with value 1 and we repeatedly multiply p with base, and this is done for exponent number of times to get the power, and then we return p. Okay, so what will happen if I just call this function without any arguments? So it will just simply calculate 10 to the power 1. Right now, one thing that you have to remember in these cases is that once a default parameter occurs, all parameters to the right must be a default parameter, must have a default value. So if I just copy this function, and if I don't give any default value of exponent, then it throws a error. It throws an error and that is a syntax error, that non-default argument follows default argument. So once you define basically a default argument, then everything to the right of that default argument should be a default argument. So if I put exponent equal to 2, and now it compiles just fine. Now let's say I just want to compute square of all the numbers. Like I just want to compute a square in case the exponent is not found. So in that case, I will just pass exponent as 2, and I can just call this function as power of 5, let's say 5, power of 10, and also with power of -1. And in all these cases, it will just print the square of the numbers in case the default value of exponent, in case the exponent is not passed. So it will just take the default value of exponent, which is 2, and it will just return the square of the input that you have given, right? The second type of arguments that a function can take are keyword arguments. So here the idea is to allow the caller to specify the argument name with values. So what might happen is you might just confuse base with exponents or so on. So once that function is compiled, you can just type shift tab, or here it does not work. Okay, let me see. Okay. So if I just execute power and I want to compute, let's say 5 raised to the power 3, right? So this power function takes argument as base and exponent, and the default value of exponent is 2. But let's say I want to pass exponent as 3 and base as 10. So what I can do is I can also pass base using the base keyword, which is the keyword argument for base, as 10, and then you have the exponent value as 3. So this will return 10 to the power 3, which is 1000. Now if you want to calculate, like say 6 to the power 0, so it will be just 6 to the power 0, and that is 1. You can also take 6 to the power 8, like 6 to the power 8. So base will be 6 and exponent will be 8, and using this you can calculate powers by specifying the base and exponents explicitly. Another way of passing the argument is using positional arguments. So what happens in Python is basically, since you are writing these types of arguments sequentially one after the other, what Python assumes is that the order in which you are passing the arguments would be the same as the order in which they are defined in the function body. So if I just write power 5 comma 10, it essentially computes 5 to the power 10 without explicitly telling that base is 5 and exponent is 10. And if I give 10 to the power 5, then it automatically assumes that base is 10 and exponent is 5. So let me just run this. When I run this, I get first value is 5 to the power 10 and the second value is 10 to the power 5. Okay. So this is just another way of passing an argument. Now, in case you have a default argument, so for example, here we have exponent as 2, you can also skip passing the second argument. You can also just pass the value of the first argument, which is just power of 5. So this will compute 5 raised to the power 2 by default, because we are just passing the base. We are not passing any exponent. So if I just run this, it will compute 5 to the power 2. Since since exponent is by default defined as s2, and Python assumes that you are passing the argument sequentially one after the other, so the base is translated automatically as 5 using this positional argument logic. So in essence, we use positional argument during the function call, so that the first argument is assigned to the name and the second argument is assigned to the not name. So first argument is assigned to the base and the second argument is assigned to the exponent. And as you clearly saw that when we put 5 comma 10, it was base was 5, exponent was 10, and when we put 10 to the power 5, so base was 10 and exponent was 5, and it was passed like that. So first argument was base and second argument was 5. Now one difference between keyword argument and this positional argument is this: in keyword argument you can pass, essentially you can pass arguments in whichever order you want by providing the keyword. So I can also pass like this: exponent equals to 3 and base equals to 10, right? This will still compute 10 to the power 3. But if I write power of 3 comma 10, then it will compute 3 to the power 10 instead of computing 10 to the power 3. So it is more safe to use keyword arguments, because even if you mess up the order, then you don't need to remember the order of the parameters. But if you are sure, if you do remember the orders in which the parameters are occurring inside a function, then you can blindly use positional arguments without mentioning the keywords specific to them. So both of these are same. The main difference is that in keyword arguments, you pass the keyword with the parameter value, that is exponent is 3. But here you can just pass the value at that particular order. So 10 will be the exponent and 3 will be the base, right? So like this, there is. So I hope everything is clear till now, that how to define functions and what are the various arguments, what are the various ways to pass the arguments to the function, and essentially what are the different types of functions arguments. I hope it was clear till now. Now we move to the second part, which is functions within functions. So Python has this utility in which you can also define functions within a function, right? So this facilitates you to carry out a subtask within the function body itself. So here what I have done is basically I have broken down the power function into two steps. First is the function which just multiplies. So this repetitive multiplication basically returns the multiplication of the arguments, and Then there is this outer function power, which actually computes the power. So what this function does is it takes as argument base and exponent for which you want to compute the power. So the inside function define repetitive multiplication. What it does is it essentially just returns the multiplication product, the product of arguments. So the product of arguments here multi of r into base, and what this for loop does is it facilitates it facilitates the repetitive multiplication to get the power, right? Repetitive multiplication. If I execute this here, since it was -1 to the power 5, it will just, this repetitive multiplication will be called 5 times, and it will multiply the base with p 5 times. So we can also pass 2, and we can also see that what it's printed. So we can just print f inside repetitive multiplication, and we can just print whatever is the exponent so far, right? And here we are invoking repetitive multiplication. Invoking repetitive multiplication. If I execute this, oh sorry, it should be power underscore. Let me see whether it works or not. Yeah. So for the first range of exponent, it just multiplied once, so it was 2, right? Then for the second time it invoked, so it 2 into 2 becomes 4. Then 4 into 2 becomes 8, then 16, and finally 32. So this is just a dummy example, but in case you want to, in case you have some complex functions that needs to be broken down into function itself. So this is just a simple way to define functions within functions, using which you can mitigate that complex problem into smaller modular subproblems, right? So this was another concept with functions. Now the next concept that we move to is defining anonymous functions. So in Python, you can use lambda keywords to define an anonymous function. So anonymous functions are basically functions which without any defined statements, and they are used to carry out simple inline tasks. So these are just functions that you can, that can be basically written in one line, and you don't need to explicitly specify or define another function for that. So here I have shown some simple examples like calculating a max of two numbers or calculating square of an input. So this max is an anonymous function, basically which is defined using the keyword lambda. It takes two arguments, a and b, and it returns a if a is greater than b, else it returns b. And second is the square function, which essentially computes squares. So it takes an argument a, and it returns a times a, right? So if I execute this, so max of 3 comma 2, it returns 3, and we have a square of 4, which returns 16. So this is just a simple way of defining like anonymous functions using this keyword lambda. Now you will not think that these are important concepts, but once you get to abstract data types and using sortings, filterings, or you want to filter out some uh, some types of values within a list or within a dictionary, then these types of anonymous function actually helps a lot by defining that logic just in line and easily filtering out the keyword without explicitly defining a function, and uh, without explicitly defining a function and making and breaking the flow of the code. So this is just a simple way to define anonymous functions, and it will help you when you actually learn the concepts of abstract data types. The next thing that I want to discuss about is returning multiple objects. So in Python, you can return one or more objects depending on the functionality you wish to implement, right? So in the above functions, since you are computing only just power, we only need to return whatever was the final product. Like we take the base as input, we take the exponent as input, we compute the expression based to the power exponent, and then we return the final answer that we get. Now, if there were cases where you need to return more than one values, so for example, consider a scenario you have to where you have to return the maximum and minimum element, right? In that case, what you can do is first uh, like basically compute the max and min, and you can just return both max and min in the same return statement, right? So you can just return max. So max will be the first element that is returned, and min will be the second element is the return that will be returned, and syntax is just return followed by whatever you want to return. So it will be max comma min, right? So let me just execute it and show you. So if I just run this, so max comma min is the output of return max min, and it just returns the maximum and minimum of the three elements that you have passed as input. So 4, 5, 6, print max min. So max is 6 and min is 4. You have to ensure that whatever is returned by the function. So here the function is returning two elements. So you basically put two variables that captures the output of the function. If you don't do that, then what functions assumes is essentially you are returning some sort of either a tuple or a list. So what would happen is if I don't give two variables and take instead just give one variable as a to capture the return of this function. Let's see what is the type of this variable, right? So essentially the type of this variable will be tuple, which is basically whatever this function returns. And to access an individual element, you can just index it. So if you just print up of 0, that means we are printing the max, right? Because max is the first element that is returned. So this will print the max. And when we print top of 1, it will print the min, right? So in this way, you can return max and min. Now, let me give you one more example. Well, let's say instead of max min, you are also requested to return the mean, max, min, and mean of the three values that is passed, right? So do that. What you can just simply do is, so mean will be equals to a plus b plus c divided by 3, and you return mean, right? So now since you're returning three values, you will need to you will need three variables to capture the output, right? So max comma min comma mean equals to return max min so return max min, and let's say I just put 6 comma 8 comma 10, right? Then I print max comma min. And when I execute this, I'll get the max value as 10, the min value as 6, and the mean of 6, 8, 10 is 8 plus, so 6 plus 10, 16, 16 plus 8, 24 divided by 3. So it is 8, right? Now the basic concept that you have to remember, the basic thing that you have to remember is in case of multiple return statements, you might also need to remember the order in which the things are returned, right? So here we're returning max, min, and mean, and if you incorrectly store max element in min and min element in max, then the entire thing will be ruined. So what if I just write like this, min, max and min, then the entire thing is broken because now the max will be 6 and min will be 10. So the important thing that you have to remember is you have to consider the order in which the things are returned, and you have to make sure that you store them correctly. Since max is the first element that is returned, you have to store it inside the max keyword. The min is the minimum thing that is returned, so you have to make sure that it is stored in the appropriately named variable, and this goes on. Now, inside functions, since you are just like you can return multiple things, you can also return based on the type that the user wants. So since here I am returning max, min and min, so user can also define the type it wants. So it can by default be min, right? Or user can specify what it wants. So user can specify that I want the mean, right? Or I want median. Let's say the user specifies that first I want the max, right? In that case, what we will do is we will check that if t is equal to max, then we return max. And if t is equal to min, then we return just the min. Else else we return the mean, because if the user does not want any of the max or min, that means it is uh, that means the user wants the mean, right? So then I will just store it in the variable, let's say answer, and I can then just print answer, right? So here, since I have passed that I want the max of two numbers, naturally the answer returned should be max. Let's see what it returns, right? And it returns the max element, which is 10. If I want to take min, then I'll just pass min and will return the minimum. And if I wanted mean, I can just pass mean and it will return the mean. I can also not pass any argument in that I want, and in that case, it will fall to the default value, and that is the minimum, and it will return the minimum. So the answer will be 6, right? So in this way, you can also return different type of things depending on different type of flows that is requested either by the user or basically the things that you want to do. Now, one thing that you have to note here is that in Python, by default, every variable name is a reference. Like we told you that every variable name in a Python is a reference, and when we pass a variable to a function, a new reference to that object is created, right? So just like in Java, if you are familiar with Java, everything is passed as a reference. In Python, the parameter passed is the parameter that is passed is reference, right? So what essentially happens is that, for example, consider this. So here there is a list, and what I'm trying to do is inside this function I'm trying to change the zeroth index of this list, right? Now, if this was a C function, what would happen is that this x would be considered local, and any changes made inside this function would not be reflected in the original input. But in Python, since it is passed as a reference, right? So x of 0, which was initially 2, now changes to 1. So let me execute to show the effect. So the original list was 2, 3, 4, 5. That is the zeroth element contain 2, but after calling this function, the zeroth element is now updated to 1 inside the function body, so it prints 1 instead of 2. Now, can you guess the output of this function? So I have x as I have this function update x, which takes a value x, right? Which is set to and sets it to 5, right? Then there is this, I take this variable x, set it to 11, and I call update x and I print x. So can is anyone first of all present here? Let me see. Would anyone of you like to take a guess that what would be the output of this thing? That will x change or will x not change? What do you guys think? Okay. So since this is passed by reference, and if I change anything inside the reference, anything inside the function body, right? What it does is, you have to remember this thing. When we pass a variable to function, a new reference to the object is created and the old reference is broken. So when we start with x as 11 and we take x as input and change it to 5, right? Even if the change happens, the value of x does not get changed because this x does not change the value of x, which was set to 11. Rather, this x is now a new reference, and that basically gets changed. But what happens if I return x, right? If I return x and set it to x and then I print x, only then this change will be reflected, right? So just to show you more clearly, first I'm printing x. The first x that is printed will be without calling update x, and the second x that will be printed will be will be after calling update x, right? So initially the x was 11, and after calling update x, since we returned this particular x and stored it inside our x, so it got the value as it got updated, and now it is 5. So following from this example, if we just do swap, right? If we just do swap on x comma y, the temp variable. So basically, we just do a simple thing that we take a temporary variable. First, we set it to x. Then in x we store y, and in y we store temp, right? So if I just pass x comma y to this variable, to this swap thing, and don't actually return anything, x and the value of x and y will not change. It will just be 2 and 3. Only when I return xy and store it on in xy, then you see that the value of x and y has been swapped. So earlier x was 2 and y is 3, and now it is just 3 comma 2. Now just a spicy nugget, you can just simply swap things in pi just by writing this. So if I write x comma y equals to y comma x, and then if I just print x comma y, you will see that x comma y has now been swapped. So x was earlier 3 and y is now 2. But after using this statement x comma y equals to y comma x, the values of x and y are now swapped. So x becomes 2. So basically x becomes y, and then y becomes old x. Right? This is how you can understand this statement. So this is just a very simple and unique way to swap things, to swap two variables in Python, and swap the values of two variables in Python. So x becomes y and y becomes x, and when you print x comma y, they are swapped. Okay? So that is all about functions. The next concept that we will be discussing is on generators, right? So in layman terms, basically a generator function is basically a generator function will keep on yielding an expression till you are calling it, and once it has nothing to yield, it stops, right? So let me just show you an example. And even before that, let me define what is a yield statement. So in layman terms, the yield keyword will turn any expression that is given with it into a generator object and return it to the caller. So therefore, you must iterate over the generator object if you wish to obtain the value stored there. and that can be done using this, which can be simply done using a for in loop. So here I have defined a simple generator functions which just yields 1, 2, 3 sequentially every time it is called, right? So when I just execute this, first it will print 1 because first we are yielding 1, then it will print 2 because then we are yielding 2, and then it will print 3 because then we are yielding 3, right? So this is just a simple example of generator functions. So basically what a generator function does is it keeps on yielding things iteratively, and using this you can basically define simple functions to do simple tasks in iterative order, right? So here is a simple example to infinitely generate sequences. So let me just use slash and hyphen at the end. So in that case, you will see that this infinite sequence, what it does is it will keep on printing numbers, it will keep on yielding numbers while we have true. Now, one way to model it is that while you can just pass a limit, right? So let's say I just want to print numbers iteratively till let's say 50, right? So define infinite sequence limit while num is less than limit, you print the numbers. So in that case, it will first print 0, then it will print 1, then it will print 2, then it will print 3, and so on till it reaches 50, and finally it stops. So this is another simple generator function which just keeps on generating. Now the ways to get output from a generator function is either using this for in loop or using the next using the next function. So essentially what next function does is it will print the next value that is in line. So here in this infinite sequence function, the first value that will be yielded is 0 because we have num as 0. The second value that will be yielded is 1, and so on, right? Till we have a limit. So if I just use this next function 50 times, it will print each of these values sequentially. So first it will print 0, then it will print 1, then it will print 2, and so on till it reaches 50. So in essence, a generator function returns a generator object that is iterable, that is can be used as an iterator. So generator objects are used either by calling the next method or by using the generator object in a for in loop, which I showed previously. So here is another example. So here is a generator function which yields 1, 2, 3, and I set and I get a generator object by calling this generator function, and by calling next 3 times I will get each of this value once. So the first next will yield 1, the second next will yield 2, and the last next will yield 3. So when I execute this, I get this. It first prints 1, then prints 2, then prints 3 because it yields 3. Now what will happen if I print, if I call yield one more time, right? If I call next of x, it will just throw an error because you have exhausted. You've exhausted the generator object. Basically, generator object had yield. It can only yield 3 values. First, it will yield 1, then it will yield 2, then it will yield 3, and you already called next 3 times. So, calling next 4 times would lead to an error, that is stop iteration, because you've already exhausted all the values that could be yielded from this function. Right now, let me show you another example. So, x equals to inf. What was that function? Uh, it was infinite sequence, x equals to infinite sequence, and the limit is, let's say, 10, right? So this x, and let me also give you the idea what is type of x, right? So type of x is a generator, right? Now what I can do is, if what if I call next of x, right? So next of x will first return 0 because 0 was the first value that will be yielded. Then again, if I call next of x, what will happen? it will print 1, because now the x has yielded 0, it will now yield 1. And every time I call next of x, it will yield the next value that is queued. So first it yielded 0, then it will yield 1, then it will yield 2, then it will yield 3, and so on. So this is just a simple generator function that keeps on yielding numbers from 0 till whatever limit you have passed. Now, can you think of a generator function that can yield Fibonacci series till a specified limit? So whoever is present in the class, if you have understood the concept of generators, that basically takes a limit and yields iteratively. Can you think of a logic using which you can yield generators, using which you can yield Fibonacci series sequentially? Okay, so the basic idea here, so how can you yield Fibonacci series, right? So let me just give you the basic idea. So the sketch would look like this, right? What are Fibonacci? So what are the starting points of Fibonacci numbers? So you have like the starting is 0. So the first element is 0, and the next element is 1, right? Then what you do is, and again you have a limit, right, till which you want to generate, right? So basically till you reach this limit, right? So till you reach this limit, so while a is less than limit, right, what I will do is I will yield a, because that is the first number, that is the first number of the Fibonacci series, and I will manipulate a in such a way that with after every yield, a now contains the next number, right? So I will just write a, b, a comma b. So essentially what this statement will do is, what this block of statements will do is, first it will make sure that we don't cross the limit. This while condition will make sure that we don't cross the limit. Then at every step we will yield the nth Fibonacci number that is in the sequence. So it will start with 0, then 1, then 1, then 2, then 3, then 5, then 8, then 11, and so on till whatever you have set the limit, right? And finally, and finally, what it does, is uh, in seventh line, basically the next part, what it does is it just swaps. So a, since a has to store the next Fibonacci number, so what it does is it will store the next Fibonacci number, which is computed as b in a, and then b will contain a plus b, because that will be the next Fibonacci number in line. So just to write a solid code out of this, so I will write define fib limit, right? Then I will store a as 0 and b as 1, and while a is less than limit, yield a, and you store a comma b as a plus b. Okay? So let's see what happens if I do x equals to fib of, let's say I want to print Fibonacci numbers till number 10, right? So in that case, sorry, a equals to 0 and b equals to 1. So then let's see what does x contains. So what is the first value that x will have? So it will be 0, right? Then it will be 1, then it will be 1, then it will be 2, then it will be 3, 5, 8, and no more, because after it we have reached the limit, which is 10, and there is no Fibonacci number after it which is less than 10. After that, after it is 13. So using next function, either you can get the next values or you can simply use a for in loop. So for I in fib of, also for I in x, you just print I. So like this. For I in x, you just print I. So it will print 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. So these are all the Fibonacci numbers that are less than 100. Okay. So this was one example. Similarly, you can also think of generating a generator function that yields, let's say, all even numbers. So that would look like this. So define all even till we reach the limit, right? So we'll just need one number here, a equals to 1. Now while a is less than limit, if a mod 2 is equal to 0, we yield a, because that means a is even, and we increment a by 1, right? And if I do that, x equals to all even 100, and then I print uh, for I in x and I, then I'll get all the even numbers between 1 to 100. Similarly, I can also calculate all odd by just changing that when a mod 2 is not equal to 0, you yield a, and when you make the call. So you change to x equals to all odd. When you print I, you will get all the odd numbers. You can also think of a generator function to yield prime numbers, and that you can do as a take-home assignment, in which you can think of generating prime numbers using this generator concept. So essentially, you have to write a function that takes a limit, that takes input as a limit. So define all prime till a limit, and basically you have to check. You have to iteratively check that from 1 to that particular limit, if a particular number is prime, you yield that and you carry on, right? So this is all more or less about functions and generators. The one basic difference being, in generators, the return statement is not actually a return statement, rather a yield statement, which does not break the flow of the function. So one important thing is that if you write return here instead of yield, right? If you write return here instead of yield, what will happen is it will just return the first odd number and it will break. It will break. Basically, this while loop will break, and x will only contain one number. So if I just print x, it will contain just 1, right? Whereas if I write a yield statement, then it converts this normal function to a generator function, which will iteratively, which basically makes it an iteratable, which basically makes it an iterable, and it will yield iteratively till either a particular limit is reached, or whatever it has to yield is completely exhausted, as we saw using using this example of calling next, right? So this is one thing that you have to remember, that if you are supposed to write a generator, you cannot put a return statement in the body. You have to put a yield statement, because the moment you put a return statement, it just returns from the body of the function to the main flow where it was called, and it can no longer do that iterative behavior which is supposed to do. So this is more or less all about the functions and generators. And the last thing that we wanted to discuss today is using the concept of packaging in Python, right? So more often than not, you will find yourself writing codes in different files in different places. Now, so basically each file will consist lots of functions, and you might need to call one function of one file into another function of some other file. So Python has this beautiful thing called packaging, using which you can import any function of any file into your code. So for example, here I have a test.py which contains the simple logic of computing factorial, right? So define calculate factorial, and it basically calculates factorial for a given number as input, right? So the beauty of this thing is that I can just import this cal factorial function into my logic by just writing from test, which is basically test.py. So from test, import this function, and I can just import this function and use it. So here I will show you a dummy example. So if let's say I just want to calculate the factorial of 5. So I will just write calculate, oh sorry. First I will import, and then I will calculate factorial of 5 by just calling this function. So the basic idea is this: if you have a piece of code, or if you have a function that is being used across multiple files repetitively, what you can do is just define it somewhere and then import it whenever it is needed, right? So for example, it can be just that you are doing some sort of pre-processing, or if you are doing some sort of NLP related tasks, then maybe tokenization or pre-processing is a very common thing. So what ideally we do is we create a simple file like this which has a pre-processing code, and every time we are supposed to do pre-processing on different data sets or on different tasks, we just call this piece of code within every new file that we create for every data set, because this code is more or less standard, and it can be executed irrespective of the data, or irrespective of the package that you want to use. So this thing is more or less constant, and it will be called every time you want to start a NLP pipeline. So this is just a basic idea. So you can just use a simple syntax that from file name. So the syntax is essentially from from the file name, import function name. Also, if you don't want to include if you don't want to import just one but all functions, then you can just call from test import star, and this thing will still work fine. So if I just execute this and if I run this, it will still work, because we have included all the functions that are defined in this test.py. So let's say if I define add two numbers as a function, add two number a comma b, and which just return a comma b, and if I call this function here, add two number 5 comma 10, save it, and yeah, calculate factorial also works, and add two numbers. Oh, add two. Was this not saved? What happened? I think this is not getting saved. I don't know. Is it saved? Add two number. It is getting saved. Then what happened?
Actually, I guess you have to restart the kernel, otherwise it will not load.
I think I have to restart. Yeah,
Yeah,
because here only it is showing from.
yeah.
This
Otherwise,
is this
there is a thing to
this is the
proceed.
problem with iPy and this node, this Google collab. I think you're right.
So that is
Yeah,
the
but yeah, I mean, if you have multiple functions, then you can just from test import star,
Or
And
one thing you can do, you can change the function name a bit. That would also work. Then you don't have to restart.
yeah, anyways, so name add to number is not defined. But from test, no, actually here it is only showing. So from test, when I call import, it is only showing that from test I can only import like L factorial. It is not showing the support for add to number. Anyways, this is just an example. When you do it in your local env, it will work fine. So this is just a basic thing. Okay, so with this I would like to end this class, and Prasenjit has something to share with you guys. So maybe you can just uh,
Ah,
tell about evaluations, and then we can close this session.
okay. So let me share my screen then. Oh, Gunjan, I don't have a sharing access.
Hmm. Okay, let's see. No, you should have.
Uh, Only meeting organizers can present and can share. You see, I guess I am.
Yeah, yeah. I think now you have.
I can share, right? Cool. Okay, you can see my screen, right?
Ah, yes.
Okay. Then so I am posting this assignment to Piazza, showing. Okay. This is the questions actually. So assignment one will be, so just read the guidelines before we approach the problem, and do not plagiarize, because we will run a plagiarism detecting software, and whichever pairs got detected by the plagiarism software, we will just mark them as 0. So you have to put your name, email ID, and then the first question will be to print the SINX Taylor's expansion series up to nth order term. So just make a function called find sin x. X would be the floating point number for the how much radian you want to input as the sin x value, and then n is the how much term you want to approximate as the in the Taylor series expansion. Okay. So and then you put your just debug and test your code before putting the answer to this text box. Okay. And the second question is from the generator functions, try to build a generator function g prime n, where n is the maximum limit up to which you want to print the prime numbers. Okay. So one testing code would be like this: g prime 20, and then you loop until the generator ends and print the elements. That desired output will look like this. Okay. So yeah, so this is the assignment. So I will share it. I'll post the link in the Piazza, where you can come here and then submit the codes. Okay, so the evaluation card and the deadline would be see, the deadline would be Sunday 12. Okay, Sunday 12, Sunday end of day. So so one thing is, after the deadline is over, we'll evaluate the submissions within, let's say, more or less 1 day, 1 or 2 days, and disclose the results. And based on the results, top 5% will be marked as excellent. Okay. And after all these assignments are completed, we will see which people are performed consistently well across the assignments, and they can apply to us as summer interns or winter interns. Okay. So so yeah, and then you will, the interview will be arranged, and under whom you want to let's say do internship, let's say me or any other lab members of my lab, right? Then they will arrange respective interviews, and if you clear that interview, then you can join us as a intern. Okay. So yeah, just try to solve the problem seriously, because this grades will be really crucial before, like at your while you apply for interns. Okay. Okay, and the deadline is Sunday end of day, so you have plenty of time before the deadline. Just, and the codes are really simple, and don't copy it from the internet, because we will catch that by the plagiarizing software. Okay. Okay then. Yeah.
Okay. So yeah, thank
Okay
you
then.
for joining.
Yeah.
Yeah,
Thank you.
I hope in today's session you learned something or other. So yeah,
Yeah. Yeah. There are many things. I also learned that the doc thing prints the doc string.
Yeah, nice.
Cool,
Okay,
cool. Okay, thank you.
so I'm closing this session and we will share the recordings and slides
Yeah,
and this collab link
yeah,
in an hour. Okay, bye bye.
yeah.